Nice. I think maybe we'll get started. If there's the last couple of people coming in, then well, the beginning's the boring bit anyway. So hi everyone. I'm going to be talking today about building and exposing your first sort of MCP server, and I'll give a bit of an introduction, less on like how you might use MCPs, but more on the how to actually go and use it and how to build it. My name is Michael. I'm CTO at a company called Bud. We do transaction enrichment and understanding of customers for PFM, cash flow underwriting, analytics, personalization, all that kind of stuff. So we'll talk through a few different things. I'll give an introduction to sort of what it actually is, and maybe like a slightly different way of thinking about what it is. We'll have a look at the kind of things that you should be thinking about before you dive in and start building something. We'll then build something. We'll build an MCP server. And then the 80-20 rule, right? It's really easy to get something up and running, but then what happens about observability and monitoring and documentation and everything that happens afterwards? So we'll look into a bit of that as well. So first of all, what is MCP, Model Context Protocol? It's a specification, essentially, that defines how AI applications should interact with a third party. It's kind of, you can kind of think about it as a, when you have an AI application and you have other things that might have context or be able to perform actions, how can you give them a really clear way of how they should be interacting? And that kind of forms two different parts. One is the transport layer and one is the data layer. So the transport layer, I'm not really going to talk about much today. That's essentially how the actual things go over the wire. And there are actually a few different options that you can kind of pick from, and then it will figure out sort of what makes sense. And then you have the data layer. Now, the data layer is what actually describes what information do you know? Like, how do I go and request this information? What tasks can you perform? How do I tell you how to perform those tasks? How should I take a user through a workflow in sort of that AI application to be able to perform a task? So it's the data layer that we'll be focusing on today, and I think is probably what a lot of us think about when we think about MCPs instinctively. So what are the different kind of components and bits that sort of form it? So you have initially your MCP host. So this is essentially your application. So ChatGPT, for example, would be an MCP host. Claude Code, your IDE. But it could also be a web application that you're building, any kind of AI tool. Now, that MCP host will then have multiple different MCP clients. You'll normally have one client per MCP server. So for example, say you've got one MCP server, which is the Google Drive MCP server, and you've got another one which is Google Calendar. Inside of your MCP host, say ChatGPT, you'll have one client that knows how to talk to the Google Drive MCP server, and you'll have another MCP client that knows how to talk to the Google Calendar MCP client. Now, one of the things that is kind of quite key is you don't want to put too much in this MCP server. What it realistically is it's almost like an API gateway. It's some documentation. So in practice, when you're building out your MCP server, what it's probably doing under the hood is it's going and doing a bunch of method calls. So that might be a method call to other internal services, your internal REST API. It may be that if you already have an API gateway for your platform, it's just going and calling that. And that might be gRPC, it might be internal method calls, it might be API calls, whatever. So there are a number of, and they're called primitives, and these are essentially the kind of key things and key parts of the client and the server. So inside the MCP server, you have tools. So tools are all about being able to execute something, going and performing an action. You have resources, which is about being able to get information. So for example, it might be the stock price of Apple, for example. And you have prompts, which are essentially ways that you can tell the MCP client on how it should go and utilize the LLM that's sort of accessible to it. Now, on the client side, there's also a few more primitives, but I'm not going to really mention those because they're not super relevant most of the time, like logging, for example. So we have elicitations. So the MCP client can go to the server, and this is where you can almost handle like back and forth, so you can ask questions. So for example, say that you have a tool which is to create a calendar event. You might go and have an elicitation, which is like confirming exactly when, oh, hey, these are the times that are available, which one of these do you want, and so on and so forth. So this is basically about being able to ask questions back. And there's another one called sampling. Sampling is almost where you can, instead of having to do a bunch of work and analysis on the server side, you can delegate it back to the client and the LLM in the client. So say, for example, that you are building something that's going to do travel recommendations. In the example of sampling, you might go and get a bunch of recommendations. You could then give back to the MCP client and say, hey, analyze which one of these might be the preferred option from this person, and then it's the LLM in the client that's going and doing the work rather than on the server. You don't have to pay the LLM cost is kind of the general sense there. So authentication is obviously a big thing. Most MCPs in practice are not going to be just, hey, here is a whole bunch of unauthenticated data, right? In practice, especially you're performing tasks, you're going to want to authenticate. You need to log into your Google account so that it can do stuff in your Google Calendar. You need to authenticate to your Stripe account before you can go and create an invoice. So with authentication, generally speaking, especially if you're wanting to expose something externally, I'd recommend implementing two different forms of authentication. The first one is the sort of default standard with MCPs, which is around OAuth and doing dynamic client registration. So that's the kind of usual OAuth flow where you would get launched into GitHub or whatever. You would go and log in there and it comes back. Sort of a standard OAuth flow. The second thing, though, I would recommend is this can be quite painful if you are trying to create trying to build agentic applications, things that are going to run in the background without necessarily a user present, etc. So instead of always relying on this, I would also recommend being able to pass bearer tokens. Now, obviously, there are things to consider with those bearer tokens in terms of like how long they live for and so on and so forth. But generally speaking, this is a lot more friendly for if you have something that is agentic, automated, sort of on the other side. So it makes sense to do both. If it's an internal use case, do whatever makes more sense and is simpler, frankly. Now, with MCP servers, and I kind of already touched on this, they shouldn't really be doing the stuff for you. One of the ways that you should probably be thinking about your MCP server is essentially a thing that does documentation in a very specific way. Because that's basically what it is. It's just a bunch of documentation being hosted and being served in a live way. And then it also becomes an API gateway, because it also will route traffic through. But what you don't want to do is put too much logic into your MCP server. It should be simply limited to what is necessary to be able to take your internal stuff and expose it and translate it to an AI application to that MCP client. So a few quick things to make sure you're thinking about before you start going and building your first MCP server. So the first one is about how it feels, how it works. Now bear in mind that you potentially have LLMs on the other side. They might make mistakes. There's retries and everything else. And this is one of the things that will also influence what sits behind your MCP server, like potentially how your underlying APIs are working. You want to think about how quickly it's going to be responding. It's potentially doing a whole bunch of other actions as well, so you want to have a fairly low latency on it, like you don't want to be waiting 20 seconds, 30 seconds. You also want to make sure you've got things like idempotency in place. The chance of it just trying to do the same thing twice, very high. Do you want to make sure that that isn't going to go and harm you in some kind of way? Do you want to make that payment, for example, twice? No, you don't. That would be bad. So thinking about those kind of how those tools will be used, and you're not thinking about a consumer, you're thinking about an AI thing, right? And an AI thing that is non-deterministic. Thinking about your schema. So again, they're non-deterministic, which means they do weird things. So the more explicit you can be about how something should work, then that's better, right? So having more fields that are required is generally seen as a good thing. If something can be an enum, make it an enum. It is possible, for example, to even refer to previous tool outputs. So in the example that we'll look at in a minute, there'll be one that's like get accounts and one that's get transactions. And one of the filters that you might want to do on get transactions is for a specific account. Now you can reference, hey, the accounts tool, the get accounts information tool, to make sure that you're getting one of those outputs. So being as explicit as possible. This isn't a Swagger open API doc that's going to be read by a human. It's being read by a machine, and it's going to not really necessarily have a huge amount of intuition on top. Think about what you want to do with authentication, which I've already sort of talked about a little bit. Security. You've got all kinds of weird things going on when it comes to prompt injection, etc. It's a machine, but it will do weird things as well. So try and think about, you should be trying to secure your inputs in the same way you would an API call that you're exposing onto the internet against various different forms of injection. Things about the maximum request size, like how much do you really want it to go and give you something, giving you massive amounts of information all at once. Again, maybe that's something that you might expect an engineer to not go and do to your platform, but an AI might just go off and do it anyway. And I think this is probably like the key thing. When you start, don't go wild. Don't make the first thing that you go and do be like, hey, I want to go and have the ability to create payments. Focus on stuff that is read-only. Focus on stuff that is going to be about getting information first. Focus on what's simple. And then you can make it more complicated, right? You can then start to improve the user experience by adding in prompts. You can add elicitations and more complex workflows. You can then start to add in the more mutating or destructive actions. I wouldn't recommend like deleting your data, for example, to be one of the first things you implement. Like make sure you understand when is an AI potentially going to go and start just calling this. So start really simple, start with read-only. And then the stack. So probably, and we were having a conversation just before the talk, a few of us, about MCPs they're very hot. Everyone's talking about them. You know, I mentioned a bunch of times in the keynote this morning, and you're all here today. But like MCPs aren't that mature right now. There is a lot of stuff that you would expect to exist that just isn't. There's stuff that just breaks. And this is natural growing pains. But different languages have very different maturities for MCPs when you're sort of building out servers, clients, etc. Now, the demo that we'll do in a moment is in Go. The Go library that I'm using, the Go SDK I'm using, doesn't have v1.0.0 released yet. Like, they just break BC for fun. Similarly, one of the kind of key things about MCPs is about how you do updates. You don't want to have to restart your server in order to be able to add a new method. And when you do add like a new method, a new API call, you want to be able to send out a notification to any connected MCP clients to be like, hey, there's a new endpoint available or a new tool. That just doesn't exist in the Go SDK, for example. Probably the most mature one is probably JavaScript, the JavaScript TypeScript one. Python feels a bit more mature than sort of others as maybe the second tier, but this is going to be stuff that changes. And I think it's one of those where, again, you don't want to keep your business logic in here anyway. You want to keep it as thin as possible. So don't think too much about, well, we're a Go house, everything we do is in Go, so we're going to go and do Go. Look at what the different stacks are and what makes sense based on maturity. And finally, keep it thin, keep it simple. So tools versus resources. So it sounds fairly clear, right? Like tools are for things that are going to go and make changes and go and do things. Resources are for reading information. So from that, if I said that something was going to go and do an API call to get the weather, you'd be like, well, that's probably a resource, right? Because you're going and fetching information. Similarly, if you're going to get like a stock price, and now, okay, if we're going and getting someone's accounts, if we're getting someone's transactions, if we're getting someone's balances, this all starts to sound like we're just getting information. But there's a really key difference between how resources and tools are utilized in AI applications, in the MCP hosts. So if you're a resource, it generally assumes that the data is fairly static, and it's a decision on the AI application when to go and necessarily bring that data in, whereas it's more likely to be an LLM that decides when to invoke a tool. So in practice, if you're doing API calls, which the vast majority of your stuff will be, it makes sense to use a tool. There are very few use cases, realistically, where it makes sense to use a resource. If you're going and fetching a file or reading a file, for example, that makes sense. If you're maybe reading data that isn't going to change, so if you're going and reading, like the company name or so on and so forth. If we take the example that we'll do later, the correct way of doing it would probably be to do everything as a tool, but we might end up doing accounts as a resource just more for demonstration purposes. The one thing that you can do with a resource is that there is a way of saying, hey, this resource is updated and has changed, but then the question is, do you know when stuff has changed? Do you have the right architecture to understand when a specific bit of data, once you know when someone's balance has actually changed, or do you need to go and do an API call to go and do that? If you need an API call to go and find out if someone's balance has changed, it should be a tool. And then it will be used at the moment of it being needed. So let's jump in. Yeah. Cool. So I built, just with Replit, a very static API which has a bunch of endpoints, so get transactions, accounts, balances. You can create spending budgets and that kind of thing. It's all basically just static data. Now, the idea here is that behind whatever you're building as your MCP server should be your existing platform. It should be your existing documented platform that has an open API Swagger file, ideally, right? You will have good API documentation ready to go, right? So you want to take the existing stuff that you have, and you want to route through that as much as you possibly can. Bear in mind, though, that there are the other considerations of you might need the usability to be different, so you might want to go and make changes. But generally speaking, I'd recommend putting it in front of whatever your existing external API gateway already looks like. So if I just do, for example, accounts. Oh, that's fun. My internet. This is always the joy of a live demo. Great, that works now. So we can see there are a couple of accounts. We can see balances, so the associated balances for those two accounts. There's a bunch of transactions in there as well. Again, sort of just some mock data in there that makes sense. Cool. So in terms of building this file here, I literally just turned around to Cursor and said, hey, use the Go SDK. I linked to it because it couldn't find it by itself, and build me the scaffolding of a Go application that's an MCP server. So there's not a huge amount of complexity in getting to this point sort of already. So here I'm creating a new MCP server. You want to give it a name and a version. If I show that there. So you've got the title and the version, which are sort of the human-friendly, the kind of things that you would expect to be seen in a UI. If you're not going to be pushing this into some kind of tool like Claude, then you don't really need to worry so much about that. If you're exposing it to external clients and you're expecting that kind of thing and not just applications you're building yourself, it's worth doing. And then the name, which is sort of more the programmatic sort of slug, essentially, that you're thinking about. We then want to create an HTTP handler. So I mentioned there are a bunch of different types of transport that you might want to do. Now, when you're doing development, quite often you might actually just say step standard in, standard IO, and then essentially it would just go and execute that binary on your local machine and then pass in. This is more what you want to be doing in production. There's also a version called SSE, which is kind of a middle ground. But this is essentially where you want to be able to stream HTTP back and forth. You're creating that transport. Now, we're then creating a normal HTTP server. So in exactly the same way that you would if you were creating a normal REST API, because essentially it's still HTTP, right? There isn't anything super special about that. It's more about what's in those HTTP calls, how are those structured, et cetera, that is where the sort of MCP specification and parts of the protocol kind of come into play. So I'm putting this at /MCP, go away. But you could also just put this on a subdomain, mcp.stripe.com or whatever. I would recommend finding a separate subdomain rather than just putting it on your existing API gateway, especially because, as we kind of mentioned, the idea is this would probably sit in front of your existing API gateway rather than on it or in it. And then we're just going and creating an HTTP server. Now, because we're just doing standard HTTP server stuff here, this also means that when we get a little bit later and we're doing things like orchestration of metrics and so on and so forth, you can use the standard off-the-shelf libraries that you have always used for logging and for metrics, et cetera, for HTTP calls. Now, that's not enough, but it will get you a bunch of the way there without having to worry too much. So there's a bunch of stuff commented out here, which I'm just going to ignore for a moment. But essentially, the idea is when you have your actual MCP, this is where you would go and add those primitives to the tool. So if I go and run this, so it's just serving at localhost 8080. If I go back to Comet, you'll see that I can hit that, and it basically just says, hey, this is an event stream, what are you doing, go away. But it is sort of being actively served there. Now, a really useful tool for being able to, when you're working with MCPs, and probably the main tool that you'll be using to test and interact with it is called Inspector. So Model Context Protocol at Inspector using MPX to just run it. And what that will do is it will launch a UI that you can go and use in your browser to interact with the MCP that we're talking about. So how readable is that? Yeah. So I've just gone and put the URL to the MCP in here. As I mentioned, you could put in standard in, and then essentially just give it a path to a binary, and then it will go and execute it. But this is what you do in production. Might as well just do it properly, right? So we'll go and connect. Now, what will happen first is something called initialization. So essentially, your MCP client and your MCP server will go and negotiate exactly what version of the protocol that they're supporting, understand what's kind of going on. So the request that it sends just looks like this. It just says method initialize, that's what it's trying to do. And then you'll get some stuff back. So you'll get some stuff around completions, so this is the stuff that's more about the client primitives, and then the basic server info, which we saw earlier. So the name, FTDC demo server, and the version number. Now, if you're a tool like Claude, for example, This is the kind of thing that when at the bottom, actually, if I can just show you. So when you see, oh, that's exciting. So when you see things like drive search here, that's what that's using. It's using the name and that information from initialization. Cool, so at the moment there's nothing going on this MCP server. There's nothing, any tools. You can ping it and it will respond being like, yeah, sure, I exist, but that's it. It's a bit boring. I mentioned about authentication, so obviously the main two kind of ways that you would talk about is with the bearer token, and then also if you're doing an OAuth flow, you can go and configure that over here. Cool, so let's go back here. Now, something I built before was I just created this file here, which knows how to call our APIs. So for example, there is a method in here that will be, let's find a good one, get balances. It knows how to do, it knows how to do the API call to get balances. Can you read that? Can you read it at the back? Or do you want me to zoom in a bit more? Yeah, cool. It's very weird having light mode on. I only ever do light mode when it's on a, because it's easier to read on the screen. But it feels weird. So here we're just going and it's just, whatever you've probably, hopefully, maybe even auto-generated from your API spec, your open API spec. So we can just call those as methods. I've done that sort of before we're here today, and it's really, we don't need to go through how to do HTTP calls. So what we're going to do is we are going to add our first tool, which will be for getting transactions. So first of all, we want to think about what the different parameters that we need to accept to this tool are. So we're going to do, oh, I wanted that. Thanks. So we're going to accept an account ID and a limit. If we go to the API client, we accept a bunch of different things in here, account ID, category, limit, offset, etc. I'm not going to go and do sort of all of these. I'm just sort of accepting the account ID and a limit for the number of transactions we might want to get back. So we're specifying this as a struct. I mentioned earlier you can depend on a previous tool's output, which I'm probably not going to do right now, but if you wanted to, then it would be with this, it would be referencing a complete reference. And then over here in the JSON schema section, you would tell it essentially which tool you were going to rely on, in this instance, the get accounts tool. But the get accounts tool doesn't exist yet because we haven't built it. So we're just going to accept a string for now. And then we'll say accept limit as an int. Now, when the MCP server is running, it's going and telling the client that those are the arguments it needs. And that's what I mean in terms of it's essentially almost like this living documentation. It's a bit like how when we think about like Swagger files, like quite often a way that Swagger files might be used is by your clients. They'll go and grab your Swagger files and they'll automatically use that to generate like SDKs or helper methods, etc., just directly from your Swagger. You can kind of think about this as that, but a sort of hosted live version of what's kind of going on. But where you know that that's going to be the case and therefore want to be more explicit because a human is never going to read it. We then also need to think about what it looks like in terms of the response. So what does the tool say when it's done? What does it give back to the client? Now in this instance, I already have these transaction objects over in the API client, so I'm just going to say, well, it's just going to be a list of those. Keep it simple. Cool. So I'll turn on word wrap so it's a bit easier to read. I might as well keep all that. I'll get rid of that now. So what we want to do is we're going to accept a few different, just import those. So we're going to accept the context, we're going to accept the session, sorry. We're going to accept the parameters, essentially the request. You can think of this as your request. It's your entire request body. So unlike an HTTP call where you have maybe some of the stuff in like the query string, maybe you have some stuff in headers, maybe you have some stuff in the body, you basically just have this one blob. It's much more like gRPC and a protobuf in that sort of way of thinking. And then what we're basically defining here what the result will look like, which is that get transactions result struct that we've just gone and created there. We're going to go and create the client and call the existing method that already exists internally. Again, we don't want too much logic here, right? We want it to be a really thin wrapper on top of our existing API. And then what we're going to return is content. So there are two different things that you would sort of expect to see in this result. So you'll see content and you'll see unstructured and you'll see structured content. The idea of content is content should always be a string. And this was sort of when early MCP days, they didn't actually even support structured content. It was only about content. Now in practice, if you're returning structured content, i.e. a list of transactions, you should be using the structured content section for that structured content. However, most MCP clients or hosts will break if you don't give some kind of the content, let's call that unstructured content and this structured content, because just saying the word content is ambiguous. So if you don't give it anything in the unstructured content, then it will quite often error. And sometimes it will just reject it entirely. That said, what you put in content doesn't have to be that useful. You're supposed to put something in there that kind of summarizes the structured content. So for example, you could say, hey, I found 20 transactions. Or you could do maybe a string representation of the object. So for example, return a JSON string as the content in there. It's kind of really up to you. Again, it's not really used very much. If you're thinking about things like network and so on, I would say just keep this simple, keep it as a quick summary. Hey, yeah, I found some transactions. No, I didn't find any transactions. And then use structured content for the actual what you're trying to return. In this instance, the transactions. So if we go back here, we'll find out what cursor is trying to get us to do. Let's move that there. We'll put in, thank you. What's why is it not like that? Jeez, no, okay, I don't want it to do that. What's wrong here? Sorry. If anyone can see my mistake, by the way, just shout at me. Cool. Oh, yeah. Cool. Okay, there we go. Sorry about that. What's not working there? That should be fine. Rounds. Okay, let's just try building it and see. Oh, that's so limit is undefined. No, it's not. Oh. I'm just going to cheat and go here where I have this. Cool. Okay, yeah, so I just wanted that. Cool. So now if we go and do this, it should build. Great. But we're not actually doing anything. We've defined how the tool should work, and we've defined a bunch of the stuff, but what we now need to do is actually add that to the MCP server. So if we go back to our main.go for now, and we'll do MCP add tool. We'll pass in the server. I will just let that auto-complete it. So we're giving the tool, turn word wrap back on. Get transactions. We're giving it a description so that it understands, again, we're talking to AI, so it needs to understand what is the thing trying to do. So actually, I'm also going to say financial transactions. And then we'll define the handler as, I'll just do good. Cool. And then, oh, why is that? It doesn't need to know that. Cool, right. So, so here we're just adding the tool. We'll go back here and go run. And no errors. So we'll now go back to the inspection tool. Now, if I try and actually just do something here, it will error out. Because essentially the connection's been broken because I restarted the server. This is one of the things I dislike about the Go SDK. If you're, like something else that I think is really important to consider is how do you keep your MCP client connections alive even when you're going potentially restarting your MCP server behind the hood when you're maintaining those persistent connections. So putting something in front of that that's going to be able to maintain those connections, some kind of load balancing, proxy, envoy, etc. Think of it very similarly to how you would work with a gRPC server. And how to sort of maintain those connections. But in this instance, I can just reconnect. But now what we'll see is tools. So there are a number of different, on each of the primitives, there are a number of different actions that you can take. So in this instance, list tools is one of those. So you can see what's happening under the hood. It's calling tools/list, and then it gets back a list of tools. So you can think of this as almost like get the API spec for the tools that exist, and it tells it all the information that it needs. So it's saying, hey, get transactions is one of the tools. This is what it's for. The input that I would need is an account ID and a limit. It doesn't specify either as required because I didn't specify either. Oh, sorry, I did specify account ID as required. And I didn't specify anything else. And then it will also say what the output is. It will say what the response schema looks like. And it will validate that against the response schema. So if you go and make a mistake and return something that's wonky, then the client will not like that. So now that we're seeing that tool over here, in the UI, we can actually go and execute and run this. So if we go and grab one of the account IDs, let's use ACCC01, and put that in, and I click Run Tool. What is happening under the hood is you can see it's gone to do that API call to that replit there, MCC mock APIs replit/transactions. It's passed in the account ID. It got a 200 back, and it then went and returned it. So we can see transactions, and we can see that series of transactions, all sort of within that structured content. And we should see also the unstructured content, so that's just the one called content, where it says found 8 transactions. Great. It's that simple for being able to sort of go and add a new tool. Okay, cool. In terms of, I'm going to just kind of show this rather than kind of going through because I'm a bit behind on time. So for adding a prompt, you would use add prompt. If we go and look at this, it's essentially going and giving it messages. So say hi to blah. We're going and giving the MCP client information on how that should work. So if I go back to, oh, not that. If we go back to our MCP server, just quickly restart that. Reconnect. We should now see some prompts, so we can list prompts. Similarly, we can list resources. So we can see info, that's one of the ones I just added in terms of content. And then we can also see prompts, where we can see greet, get the prompt, and then we can see essentially what it's going and saying that how that should work. Cool. So let's go back to, nice. Cool. So thinking about things when you're headed towards production. So one of those is deployment. I've kind of already touched on this a little bit. You're deploying it as you would a normal service, realistically. Whether that be Go, Python, etc. Do your normal deployment process. Don't do something special. The one thing to think about is whether or not you want to put something in front of your MCP server so that you can make sure you don't break those connections when you go and restart what's happening under the hood. If you're going and doing and using the TypeScript one, and I think the Python one, you can do hot reloading. So you can go and change the underlying, essentially, the tools that are being exposed and being declared without having to go and restart the server. And what's also really cool in that scenario is it will go and do something called a notification to the client. So it will go and say, hey, I now have a new tool available called create a spending budget, and that will pass it through to the client, and the client is now aware of that without having to change sessions or refresh or anything else like that. And obviously that's super critical for when you're making changes to existing tools as well. So maybe you've just added a new field that is required, for example. Observability. So the vast majority of the time, I would say think of an MCP server as documentation, as like hosted documentation. But when it comes to anything that's resilience related, you should think of it as an API gateway. So, you know, what would you currently do on your API gateway? You want to do things like going and getting your, like declaring a request ID so you can start doing tracing. You want to do some logging. Hey, this request hit the platform and was successful or it wasn't. You want to think about your metrics. You know, what kind of load are we seeing? Now, I'd recommend trying to orchestrate as much of that automatically as possible. So you can just put middlewares on the inbound and outbound. Again, we're mostly thinking about this as a gateway to calling other APIs. So putting automated tracing in there so that you don't have to think about it for every single one that you're declaring. Prometheus metrics is an interesting one. So by all means, go and bring in the default HTTP ones. They don't end up being super helpful. What you're going to end up realistically doing, and this talks to maturity, there isn't something out of the box for Prometheus metrics for MCP servers in any of the languages that I could find. So what you'll want to do is declare some Prometheus metrics. You'll want to split out your tools versus your prompts versus your resources, and maybe even ideally handlers in the same way that you would if you're thinking about HTTP calls. And you'll want the usual sets, so things like latency, gauges, and counts. Alerting. So you've built this MCP server to understand how to call internal APIs. If suddenly the contract breaks between you and an internal API, you should alert on that, because it means you've screwed up, right? The user hasn't screwed up, you've screwed up. Because you're either defining your MCP server wrong to the client, or the contract has changed for some internal service or some other engineering team or whatever. So I wouldn't wait for it to happen twice. If it happens, alert on it and respond. When it comes to testing, Manual testing, so something you'll end up using a lot of is the inspector tool, but also it is worth using, like you would then also likely integrate it in something like Claude to be able to interact with it, but it depends what the purpose of your MCP is. You should do unit tests on your schema. So when you're thinking about what are your inputs and your outputs and validating all of that, that's where unit tests are valuable. You then want to think about integration. So with integration, my suggestion would be use your existing open API specs that you have about your existing APIs, generate a mock API that you can essentially just go and run from that will give the mock response data. And then you can just spin up your MCP. You can do the calls to it. Creating an MCP client is very, very simple. It's maybe 10 lines of code that you can then go and use to go and test that. I'd highly recommend doing that to make sure that it actually works and that you're getting that follow through to the open API spec and nothing's breaking. And then the final thing I would say is fuzzing as well. Fuzzing, I think, is quite often seen as only a security thing. But the thing is that why I'm suggesting fuzzing here is I think it's about more than just security. It's also about like a model just doing weird things that you might not expect and throwing random junk at you. You want to make sure that you can handle that well. So fuzzing those potential different prompt inputs because it might happen not maliciously as part of a usual process. In terms of the documentation you need, it's quite simple because the whole point is it's basically a documentation server. Your documentation for your MCP server can probably be one page. You need to tell someone the URL, mcp.bud.ai or whatever. How to authenticate, especially like which methods you're using in terms of bearer tokens, OAuth, etc. And then just your list of tools. It's annoying if someone has to get the inspector out just to go and find out what you actually support and is it worth them using your MCP. Yeah. Sorry, I've overrun slightly and I'm being told off. I will wrap it up within the next 2 minutes, I promise. So production hardening. These are the things that I would suggest you do too when you're like, okay, cool, this works. But like we want to make this a bit more solid before we roll it out. Authenticate every single call. Don't just wait for the calls that require like user context. So also do things like authenticate your list tools, the different lists that you can do for what the MCP server is exposing. Add in rate limits. LLMs do weird stuff. Sometimes they will just start throwing stuff at you. Adding in rate limits is essential there. Circuit breaking on what you're doing behind. Have your automated contract testing for all your API changes to make sure that someone isn't going changing the API behind and you're not updating your MCP server. And then try and do a bit of chaos engineering as well. Again, it's an API gateway, but it doesn't necessarily have all of the stuff that a mature API gateway might have. And that's that. I'm very sorry for overrunning. I will do questions, but I'm going to have to do them, I think, out in the corridor. Otherwise, someone's going to murder me. But yeah, we'll do Q&A just outside. Thank you very much, and I hope that was helpful.